So we got this rectangle ABCD. We're supposed to rotate it clockwise 180 degrees around the point P. So when you make a rotation around some point, the distance from B to that point should still be the same. The distance from A to that point should be the same. It's just in a new location. So when we're trying to select the correct answer here, B is supposed to be closest. That rules out this option, right? Because C is the closest here. That's fine. Maybe that's the correct direction of the rotation, but it's not the correct figure because B is no longer the closest. B isn't the closest in this one. B isn't the closest. This one is the only one that has B is the closest. Okay. D is the furthest, just like it's supposed to be. So that's the only possible answer there. Let's see, so we need to rotate ABCD clockwise 270. Look, if you look at all the 4 points, A is the closest. So whatever our rotation is, A should still be the closest. A is, in our original figure, A is 1, 2, 3, 4, 5 to the right and 2 up. So something, if it's going to be A in our translation, it should be 5 to the something and 2 something in the other direction. And it's 270 degrees rotation, so that's going to switch the horizontal and vertical. Look, we can rule this one out because A in the translation is no longer the closest. This one, maybe A is the closest. 1, 2, 3, 4, 5, and 1, 2. So A is the closest with this one. So that's a possible option. A is the closest in this one too, so that's another possible option. A is not the closest, so we're going to rule that out. Right, so we could try to figure out the other pieces. A and B are 3 apart from each other, so that means this is an option. A and D are 3 apart in this one, so that we can rule out this option. This is our rotation that we need. Okay, so keep in mind, when you make a rotation around a point, all the points in your original figure should still be the same distance to that rotational point. Maybe one more here, one that's kind of crooked. A is the closest, C is the closest in this translation, so we'll rule that out. A is the closest, so this is possible. A and D are one of the short side distances apart from each other. This one got switched to A and B, so we can now rule this one out. C is the closest in the translation, so we're going to rule that out. A is the closest here, so that's good. And then D is a short distance away, so that's good. This is our translation. When you rotate a figure 90 or 270 degrees, just keep in mind that the distances, like if something is 4 down, 3 to the right, now it should be now the vertical and horizontal should be shifted. So now it should be 3 down, 4 to the right, or vice versa, depending on whether it's 90 or 270. So like for this one here, we can focus on one point at a time. So I'll focus on this point right here. That's 1 to the left, 0 down. So if I'm making a 90 degrees rotation in the direction of a clock, it was 1 to the left and 0 down. Now I'm going to say it's 1 above and 0 down. Right? A clockwise rotation means I'm going like this, and it's only 90 degrees, so I'm going to switch the horizontal and the vertical. It was 1 to the left and 0 down. Now it's 1 up and 0 down. It wouldn't make sense to make it 1 down, right? Because that would be a 90 degrees rotation counterclockwise. So yeah, just taking one point at a time here. So like for this next point, it's 2 down, 1 to the left. And if I'm going clockwise, now it should be 2 to the left and let's see, 2 to the left and 1 up. Right, taking this point here, it was 2 down, 1 to the left. I need to switch the horizontal and the vertical, so now it's 2 to the left and 1 up. And then for this final point, it's 2 down, 2 to the right. So if I'm going in the clockwise direction of a rotation, I need to be going this way. So now it should be 2 down and 1 to the left. There's our figure.